Onodeko, have you told him the T-square is with you?
Yes, sir.
You've informed him, okay. The crank of a slider crank mechanism rotates clockwise. You know what clockwise is?
Yes.
The crank is 150 mm. Give me paper. So maybe if I'm writing, you understand better. Give me Biro. So let me be repeating the same thing. The crank so the crank of a slider crank mechanism rotates clockwise. You know what clockwise is? Muiz, where is Samson? So clockwise is like this. Like this, okay. Please let's get to work, please. Please. So it's rotating clockwise. The crank is 150 mm long, and the connecting rod is 600 mm long. Okay. Crank is 150 mm long. So let's give it any alphabet. I'm the one that gave it all these alphabets: O, A, B, A, B, O, C. So it will be better I use this alphabet, so that if you snap this note, it will not confuse you. Because if I start using PQ now, it will start confusing you. Let me just use O, A, B, A, B. So, and what? Where's the angle? Angular velocity. Determine the angular velocity and angular acceleration of the connecting rod at a crank angle of 45 degrees from inner dead center position. So we have been given 2 dimensions. The crank is 150 mm. Let's put that point as O. Okay, the point where we are picking the crank from. Let's put it at O. Good morning. You want to see? Okay, let's put that point as O. Let's put the end of our crank as B. Okay. Okay, so OB, which is the length of the crank, is equal to what? 150 mm. That's what? 15 cm. That's what? 0.15 meters. This. So now, they said the connecting rod is 600 mm. You know when you have your crank like this, maybe this is the fixed part. The connecting rod will be connected to the crank this way, okay? This will be the fixed part. So if you have your connecting rod at angle 45, at angle 45, at angle 45, okay? Yes. Your connecting rod will, if this is the fixed point, okay? Yes. If we have taken this place as our O, this is our B, and they said the connecting rod is 600 mm, that means this place is 150, this place is 600. It's connected to something. So this is different from the one we did last week. Let's say it's connected to something that is sliding like this, like a slider like this, but this part is fixed. So as this one is moving like this thing will be going, this slider will be going like this, coming back like coming like this, as this one is. So this B, what did I use here? A, is it A? I used A.
Okay.
Who has what's the name of this thing? Compass. You have it. Bring it. So mm. So let's call this place our A. Okay. AB. AB is equal to what? 600. I need to rewrite it so you will understand. 600 mm is equal to what? 60 cm. That's what? 0.6 meters. You get it now. So what are we given again? They said angular velocity and angular acceleration. That's what we want to determine of the connecting rod at a crank angle of 45 degrees. That means this place is what?
45.
Are you getting it now? Now, right? 45 degrees. So that's why I said BOA. BOA. That alphabet in the middle is the place where the angle is sitting down. So angle BOA or AOB is equal to what? BOA is okay, Abi. It's equal to 45 degrees in the what? In the clockwise direction. So you get it now. So now the first thing we do is what? We draw our what? We draw our what? Space diagram. So to draw our space diagram, let's look if we are given any acceleration or any speed. So which speed are we given? They said a crank of a slider crank mechanism rotates clockwise at a constant speed. When it's at a constant speed, there will be no angular acceleration. So when there's no angular acceleration, there will be no tangential acceleration, according to what we did last week. Constant speed of 300 RPM. So this one is what? Is revolution per minute. Now we need to get the radian per second. We need to get the meter per second. So N is equal to what? 300 RPM. W is equal to what? 2 pi N over 60. What is N? 300. So W, the crank is rotating at what? At a constant speed of 300 RPM. That means this is W what? OB. OB is crank. W what? OB. Where is it? It's there. WBO and WOB is the same thing. Yeah. So 2 pi N over 60 is equal to what? 2 times 3.142 times 300 over what? 60. One. Use calculator. What's it? What's the answer? So now we'll now look at what? Velocity. Huh? Okay. Velocity OB or velocity BO is equal to what? We already said it that VOB will be equal to what? Omega OB times R. This is equal to omega OB times R, which is BO. Okay? Which is equal to 1.42 times BO, which is 0.15 meters. You know 0.15 meters now. So multiply. So VOB is equal to what? 0.4013 meter per second. Okay? Are we getting it? So you may not need this one because this one is rough. You snap this one that is neat. Okay? So but let me be doing it as if I'm on the board. So anyone that is different, I don't think anyone is different. Who gave us the? You said 0.4.
Yes, 0.47.
Press it again. Press it again. You have given me wrong answer.
31.31.
Huh?
31.42.
The answer is 4.71. Stop giving us wrong answer.
4.71.
Okay, now we've gotten this. Then let's move to our what? Our what? Let's move to our what?
Our next question.
We've not even drawn space diagram.
Yes.
Should I don't know. I need to go, man. Go and eat. If I want to know if she can cook, I will ask Fatai. To buy for Bauma, any problem?
Big problem. Yes, on a picnic go and what you go? Feel good. Better.
45, right? Wait. Okay. 150 mm. What is it? We change it to what?
15 meters.
What scale are we using? We didn't even talk about scale. Scale for our space diagram. Space diagram. Which scale are we using? This is 150 mm. This is 15 cm. This is 600 mm. This is 60 cm. Divide 150 by 50. 150 by 50 will give us 3, Abi? Yes. Let 50 mm is equal to what? 1 cm. So 150 mm is equal to what? 3 cm. So this place is 150. So we are measuring 3 now. Okay. Three. Okay. Okay. So this is what? Our hole, right? This is our B. Okay. Now the connecting rod is what? 600 mm. 600 mm. But we don't know the length of OA. So since we know the connecting rod at 600 mm, 600 mm divided by what? 50. 60 over 5 is 12. Right? 600 divided by 50 is what? Is 12 now. 500 divided by 50 is 10. That means 600 mm is equal to what? 12 cm. So now you come and measure your 12. I'm not taking this topic next week. Oh. So if you like, understand today. If you like, don't understand. 12. I can see people that were not attentive last week, they are now very attentive today because they've gone home, they did not get it. Eh? Yes. 12. Okay. Then you put it here. Right? You mark your 12. When you mark the 12, this point, when you take this point to this point, is the 12. You get it now? So if they say this is a crank, this is a connecting rod, that means connecting rod is connected to something, right? So let's say what is connecting, the connecting rod is connected to is here. It's always a slider that is moving, right? So this slider cannot move up, cannot move down. It can only move this way. It can only have a what? To and fro motion, okay? It can only oscillate in a what? In that direction, single direction. So the direction will be like this, like this. You get my point?
Yes.
But this one will be going like this one will be trying to drag it. But since it's attached to this point, it will move this way. If this one gets here, this one would have been here.
Yes. Go back.
Don't worry, we will soon shoot him with compass. I will assign Samson to stay beside you with divider. If you say rubbish, he will shoot you.
Double exhaust.
If this boy should say rubbish, shoot him.
Double exhaust.
So this is our A. Okay. So the movement of our slider in respect to this crank, let's call that movement. Let's call the displacement or the point where it is at a time. Let's call that one G. Let's call it G.
G movement.
G. So that is it. So now we have drawn our space diagram. Let's move to our velocity diagram now. Moving to velocity diagram. Velocity. Okay. Velocity diagram will be based on the scale of the velocity we've calculated for VOB. But before that, let's draw a vector that is showing the direction of movement of B with respect to O, the movement of the crank. The vector moving with respect to O, which O is the fixed point and OB is the crank. The vector of the movement of the crank OB is a perpendicular line to what? To OB, like this. Okay. We can call this one VBOT, VB. If you say VOB, you know it's B that is moving with respect to O. It's still equal to what? VB. So this VOB, where is it? This VOB is still VB. So now that we've calculated VOB, now we want to draw our velocity diagram. Let's take our scale. Since VOB, the movement or the velocity of the crank is what? 4.71 meter per second. Okay. Let us use this our scale based on this. Then let 1 meter per second equal to what? 1 centimeter. This one is easy. So now we now go to our diagram. Indicate first that this one is fixed part. Okay. We indicate that this is fixed part. Then the fixed part OA we indicate it with a what? With a point. OA. Photocopy is here. I know OG is a familiar term. OG. So now, from our fixed point OG, from our fixed point OG, now let's draw our vector what? Or let's draw our OB. Our OB now will be a line perpendicular to what? BO. That is this. That is this. The perpendicular. I hope his credits are large. You need a perpendicular line.
Yes.
to what? BO. This is it. This is a perpendicular line. If I should bring this one down, if I do it this way, this line is perpendicular to this. You know?
Yes.
You don't know?
Yes.
Okay, let me use another method. Perpendicular line. This is a perpendicular line. This is a perpendicular line to OB. Let me use right. This is a perpendicular line to OB. So I want to transfer the line. You can see it's correct.
Yes.
You can see it's correct.
Yes.
So from our scale, we have 1 centimeter is equal to what? 1 meter per second. So 4.71 meter per second. So that would be 4.71 centimeter. Since it's moving towards B, that means it's going up. 4.7 4.671. Okay, are you getting it? So that is it. These are points what? These are points what? B. Now A what? AB. We need a perpendicular line which is perpendicular to what? AB. A perpendicular line which is perpendicular to AB. Let's do something this way. We can have it this way, or we can also have this way. This is a perpendicular line, right? Okay. This is perpendicular to this. Okay. Are we correct? Okay. That means we are drawing AB. This is a perpendicular line to what? AB. This is a perpendicular line. Now, this one can only move this way.
Yes.
So we are not drawing a perpendicular line to this now. We are drawing a parallel line to this because it can only move this way. So now let's look for a parallel line. A parallel line to this. Come. A parallel line Voila for transfer. Yes, parallel line to this. I don't understand what you are saying.
Like so you come out leg bay.
I don't understand what you are saying. What is it? Okay, so this point now is our what? Eh?
AB.
This point is our what? This point is our what? BA, right? This BA, right? Eh? This AO or GO. So this point will be our A. You get my point now? Since this OG is here, that's it. So what else do we need? Is it different from what we have? Is it different? Is it different from this?
No, sir.
Is it different?
No, sir.
It's not different. Yeah. So now, from our O to B, we have our what? VOB or what? VB. From our B to A, okay? We have our what? VBA or VA. So GO is the fixed point. So A is moving. So that means it's what? V or VAG or VAG or VAO or anyone. So these are what? These are velocity diagram. So now let's calculate for what? VAB and what? VA. I've done it here. I have my table. We are calculating for what? VBA and what? And what? VA or VO or VOA. You can see I wrote O, G to A. It can be VAG or VOA, anyone you want to put it. So then you use it to form your table like this, like the one you did last week. So how do we calculate BA? How do you calculate BA? Velocity for BA. You put your ruler. You measure this place. B to A. This is what? I don't know. This one is different from what I have. 2.6. 2.6.
Yes, 2.6.
One of my transfer is not correct. Because this one I have 3.3. It's not. We are getting all the step though.
Getting it, we are.
OA. That's what? 4.2. This one is 4. Almost 4.5. This one is 4.5. This one is 4.5. This one is 2.6. This is like 2.65.
Yes, 2.6.
So V, should we form our own table?
Yes, sir.
Length, velocity, radial acceleration, v square over r in meter per second square, tangential acceleration, in what? Which is equal to angular acceleration times r. This one is also in meter per second square. And what? The acceleration itself, which is what? Radial acceleration plus tangential acceleration, which is also in meter per second square. So OB, BA, OG to A. That's, you can be OA or GA, anyone. This, oh, my laptop should not fall down. Go back to where I told you to stay. Go back there. If you see any rubbish, she's expected to shook you that thing, shook you like 3 times. Because for you to leave that place and come here, that means that one you already have outstanding 2 shooking. You need to be shook like 2 or 4 times. Maybe your mouth used to do pro. Gun compass. So length OB is 0.15 meters, B is what? 0.6 meters, and OG is 0.6. Oh, you can measure it. Oh. That should be. Wait. Oh. This is 13.2.5. Convert it. That's 13.25 cm. If 200 or if 50 mm is equal to what? 1 cm. So 13.25 times what? 50 is equal to what? Is equal to what?
662.5.
662.5. Divide by 1000. 1, 2, 3. It's equal to what? 0.6625. So that's where I got my own 0.66. So 0.6625 or 0.663, anyone. So, but OG, so OG, where's our OG? This OG, that's 0.663. But this should be G to A. This one is not supposed to be having O. It's supposed to be G to A. But G to A, we can't actually determine it because it's. So that's why I mark it empty, dash. But we can determine the velocity by measuring from here to this place. And we've measured it. What did we have? We measured it and we have 4 point. We have 4.5, right? We have 4.2 here. So the velocity there is what? 4.5. This one, OG, is fixed. No velocity. This one is 2 point what? What did we measure in this one? I think it's 2.7. Six, 7. What's there?
2.65.
2.65. And this one, we have done this one before, 4.71. This is the first one we did. Please and please, always remember that you are using scale. It's because the scale I use is 1 centimeter is equal to 1 meter per second. If the scale is not like that, you can't measure and go and write it. You have to convert it back. So that is it. Now let's move to what? Radial acceleration. Radial acceleration for this will be what? 4.71 times 4.71 all over r a raised by r v square over r. 4.71 times 4.71 all over r. R will be OB. R is the OB, the length. OB 0.15. So AR is what? Give me. 147.89. So that is that one. So for this one, the other one is 2.65 times 2.65 all over 0.6. So what's the answer?
11.7.
Which calculator?
0.6. 11.7.
This one has no what? Movement. So it cannot have what? It cannot have radial acceleration. This one, they said the speed is constant. The speed of the crank is constant. That means it cannot have what? Angular acceleration. And when there is no angular acceleration, this alpha is the angular acceleration. When there is no angular acceleration, there is no tangential acceleration. That means acceleration for this is equal to what? Okay? But this, let's calculate for this. For us to calculate the tangential acceleration for this, we need to draw our what? Acceleration diagram. That's the next stage. Okay? That dark. So, from our acceleration diagram, we'll be able to get what? The tangential acceleration. So, we come here. Okay? 4.71, Abi?
Yes.
We first pick a point. A point O, OG. OG prime. Okay? Then we draw our what? OB. How do we draw our OB? We draw a parallel line to OB. And we transfer the parallel line to OG. OG prime prime. Some people will sweat. The day I will give test. That day I will know maybe it's your original skin color.
Oh, that is so.
Kò tí ì mọ nǹkankan. Kò tí ì mọ̀ mí. Ayé ND ló máa pè. Ó mọ̀ pé orí mi máa ń reboot. Orí mi ti reboot. Mi ò mọ kọ́lá animal ṣàwọn mọ́. Ó rẹ̀ mí. This transfer of line na problem. Seriously, if I use my hand, ordinary my hand gone, we transfer it. What is your problem?
Like how many hours are we?
That's your own problem. Oh. If I'm not teaching you, I won't be slow like this.
30 minutes.
If I'm not teaching you, I won't be slow.
Oh, okay. So I should test 30 minutes below 2 hours now. 2 hours in test now. Then I will take my brain 2 hours, 3 hours. In the studio.
So OG prime to B. Okay. We are drawing the radial what? The radial component of the acceleration. Since they said, where's the question? The question says the crank of a slider crank mechanism rotates clockwise at a constant speed of 300 rpm. when it's at a constant speed, there will be no tangential acceleration. So we're only drawing radial acceleration now. So there's no tangential acceleration for OB. Since it's at what? Constant speed. So there is no angular acceleration, there's no tangential acceleration. So OG to B prime at what? 4 point. Where's our table? At 4.71. Okay. 4.56. Please tell others so there will be carryover in this course. And daddy ẹ bó ṣe pè mí ní daddy ní nd nìyẹn. Okay, ìwọ ló sọ bẹ́ẹ̀. Okay, mo gbà bá jẹ́ pé òun ló sọ bẹ́ẹ̀ mo gbà. Because he was my project student in nd.
Oh baby, okay.
Ṣé ẹ náà wà ní báyìí? Ìyẹn náà wà.
So
Stop playing.
BA, right? What's our BA? 2.65. BA. A parallel line to what? BA. So this one we have both radial acceleration and tangential acceleration. So BA. We are drawing parallel line, right? This thing now. Wow, all this parallel. This line, zip. I think this one should be parallel. Who said he slept by 3? Who is this person? Okay. This one said he woke up late, have you? You now said you woke up early, that's why sleeping by 3. And you go to class at the normal time. When did you wake up? Yes. 6. So why did you come late? So why did you sleep? When did you sleep? When? What time? When? You slept 3. What were you doing till 3? Are you into game? So what were you doing? Nothing. You were watching film. It's correct. Yeah. So 2.65. You're 2.7. Right?
Yes, sir.
2.65. Who's there? Hello? I'm still in class here. Yeah. 8 to 10, 10 to 12. 8 to 10, 10 to 12. Even if the person taking the course is not careful, the person will miss it. 2.65. Bring that one for me. Bring that one under the table for me. Diagram. This one. to draw acceleration diagram. This one to draw velocity diagram. I got to class before it.
3 hour test. 3 hour test.
Okay. Sorry. Let's pick our scale for acceleration diagram scale. From here, this 147.89 meter per second square. Let's pick our acceleration scale. So, what can we use? 147 divided by 50. What's the answer?
2.94.
147 divided by 50.
Yes, 2.94.
2.94. 147 divided by 40. Divided by 40.
3.675.
3.67. Divided by 30. I want something a bit big.
4.9.
4.9. Divided by 20. I want it to be like around 8.
7.35.
Okay. 147.89 over 20 is got what?
7.35.
7.35. Okay, let (20 meter per second square equals to what? 1 cm. Okay.
Yes, sir.
So that means 147.89 will be equal to what? 7.35 cm. So 11.7. 11.7. If 20 meter per second square is equal to 1, this one is equal to x. 20 meter per second square is equal to what? 1 cm. So this one will be equal to x. Cross multiply is equal to what? 11.7 times 1 over what? 20. So x will be equal to what? 0.585 cm. That means 11.7 meter per second square is equal to what? 0.58 cm. So let's use these two for our acceleration diagram. Please. This thing used to confuse, so you can know it and you get to where you want to do it and you get confused, because I was already using this one now to draw it, and last week I did not use this one to draw it. Last week I used this, but today now I'm already putting another one. But when I saw the diagram, I noticed the diagram is wrong.
Not correct.
But if you know it, when you are drawing, if you have done mistake, you will know that it's wrong. You know, last week when I was drawing it, I didn't even do mistake in calculation, but when I was drawing, I noticed it was wrong because I was transferring. When I used my hand to transfer, only hand, free hand, it was accurate. So please, let us know how you will do it and we won't give ourselves mistakes. So now, OB, which is what? 147.89 is what? 7.35. OB. Parallel line to OB now. Parallel line to OB. We can still use the former one anyway. I think use the former one. O prime G prime. You know, I've transferred the line initially.
Yes.
So what I need to do now is to measure 7.35. 7 point. I did mean I've started eating Bola's pomo now. We think it's the pomo that is making me do rubbish. 7.3. 7.35, right?
Yes, sir.
Okay. 7.35. Okay. So now that's we can even use this thing to mark it first before 7.35. That's what B prime, right?
Yes, sir.
B prime. Now we need AB. Let's transfer parallel line AB. AB will be what? 0.58. 0.58. So this is in what? This is what? A radial OB. Okay. So no tangential acceleration for this. If there's tangential acceleration for this, what we do is to what? To draw a perpendicular line to the what? To this. Can you remember what we did last week? If there's tangential acceleration for this, we just put our protractor here and draw a what? A line that is perpendicular to this as our tangential. But there's no tangential acceleration for OB. So let's go to AB. AB. Had it been this thing is only drawing, it would have been fine. It's both drawing and calculation. If you don't know the calculation, you can't know the drawing. If you don't know the drawing, you can't know the calculation. You can see everywhere feed up.
Yes.
You can see another page feed up. Okay.
Fatal. Don't want 30 minutes. 30 minutes first.
You know the funniest thing? Some people
Fatal.
will not come to class. They will be in class, they will sit at the back. They will still not know it. They will be looking for somebody to teach them that they were in the same class. Some will sit at the back. If you check this class now, some will be at the back. How will Said see what I'm doing? He cannot see.
Ojú mẹ́rin ló ní. Méjì wà ní.
There's no space. What is he saying? HOC. Why would you say HOC is not getting it? What do you mean? Are you the one that helped him to do his ND?
Don't worry.
Don't talk to HOC anyhow. He was my project student. I can vouch for him. I can vouch for all my project students. Except Yusuf. Except Yusuf. Naira. Yusuf. Baba Were. Is your husband? Why are you selling pomo? Your husband is driving. Okay. If Yusuf is your husband, you are supposed to be driving Lexus. She shows to sell pomo.
Supposed to be selling clothes na direct.
Yeah, I think we right. This is already above it. Should we take it like that?
No, the measurements are wrong. About my calculator.
It's above it,
above
like point something.
Yes.
Let's just continue.
Yes.
I remove .1.
Like
Because I get.
So that we will not get wrong answer.
We should say
Nice.
Okay. So now, this is what? AB, right?
Yes.
This is the radial acceleration for AB. At what? 0.58. 0.58. What do I have here? My own is different. My own should be up to. Mine is 0.9. Diagram is because of the diagram. That's why we have different answers. 0.58. That's like 0.6,
Yes.
right?
Yes, sir.
0.58 and 0.9. So okay. So at this point, after measuring it, this dot, that's the point where you will draw your what? Tangential acceleration. Okay. Then okay, this is 90, right?
Yes, sir.
Then you have something like what? Like this. Okay. Are we in line?
Yes.
Okay. 2. Okay. Now we need what? This OG. AG or AO. There's movement of A with respect to O. If our fixed point is OG, there's movement of A on this OG, but the movement is like this. The movement is like this. Because if this crank, this is a crank, from here to here is a crank, is rotating this way. I have it here. This OB, this OB. This is the OB, this place to this place. And this one is rotating clockwise. It's rotating clockwise, like this. So when this thing moves to this place, it will drag this thing. And this thing will drag this one. So this one is here. So there's movement of this A with respect to what? This place to this place. With respect to 0 to G. So that means this one, this point, cannot go like this. It will only go this way. So that means we need something parallel to this. Then something parallel to this must be in line of what? OG. That means we need a parallel line which we will move from here to point OG. Do you get my point?
Yes.
This is what? Tangential acceleration for what? For A, B. This point, this one is radial acceleration for AB. This tangential acceleration for AB. So moving this one, how do we get a parallel line to this? If you know this diagram, the calculation is not going to be a problem because the calculation is not hard. You understand? The calculation does not have plenty formula. It's the diagram that is problem. That is the problem of it. Okay. Okay. Right. I think we have successfully transferred it. Right. Transfer it to G. Okay, so this point is your what? Is your A prime. If this is the radial acceleration for AB and this point to this point is the tangential acceleration for AB, the acceleration for AB itself will now be from this place to this place. This will now be the acceleration for what? A, B, which we can call acceleration of A because it's A that is moving with respect to B. You can also say acceleration AB is called to what? Acceleration of A because it's this A that is moving with respect to this. So this arrow will come this way. Do you understand? So now we're almost done. Are we not almost done? So what we need now to do is to measure and to calculate. So what is the tangential acceleration for BA? Where is BA? BA. Tangential acceleration for BA. You measure from here to here. That's what?
6.3. 6.3. 35.
6.35. A tangential AB from measurement from or from acceleration.
There we go.
Okay.
That's all.
It's 6 point what? 6.5, right?
35.
35.
Yes.
So let us not have. What's there?
6.35. But what was it for?
6.3. 5 cm. Okay.
Yes, sir.
If 20 meter per second square is equal to 1 cm,
Yes.
so A tangential AB is equal to what?
6.35 divided by 20.
Is equal to what? 6.35.
Divided by
That's what? 6.35 times 20 all over what? 1 is equal to A raised by TAB. So 6.35 times 20, calculator, sharp.
6.35
127.
127.
27.
1. This one is 6.35, abi. 127 meter.
5 the quarter.
127 meter per second square. Okay. So now we know that A tangential AB is equal to what? Angular acceleration AB times what? AB. A tangential AB over AB is equal to what? Angular acceleration AB. So 127 over AB. What's AB? AB 0.6 is equal to what? So angular acceleration AB is equal to what?
1.6.
1.6 meter per second square. So which other one are we looking for? That's the what?
AB.
We've done for AB.
Yes, sir.
We've brought out the tangential acceleration. Which other one again do we need? Any other one you need, you can bring it out, right? Which other one should we bring out again? Where's our table? We've done for this, right?
Yes, sir.
We've done for this. So when you get this, we've calculated for this. When you have this, when you have this and you have this, you can have this. If you want to go and use ruler to measure it, you can go there and use ruler. This acceleration, you can use ruler too. Okay, but if I want to give you a question, I will tell you that what's the difference between your calculated acceleration and the one from your acceleration diagram? That means I expect you to add your tangential acceleration and radial acceleration, give me the acceleration, then go to your diagram and measure if there's any difference. You understand my point? So you know, if we measure here, what we just do is to convert it based on the scale and get the acceleration in this point. Narrate, are you getting it? You are getting it, okay?
Yes, sir.
Kunle, Onodeko, more plantation, Agosu. Where is Oba? Stay here. Stay here, where they can shoot you with needle. Who is your wife? Who gave her to you? I can never give Ramot to you. I know. I assign her to you to deal with you. It's not for her to marry you or to be your girlfriend. If I want to assign Ramot to someone, I know the type of people I can assign Ramot to. You, if I assign you to Ramot, no. You are not compatible. I know the kind of guy that can fit Ramot's life. So we've calculated this. We've made, so which other one? OG is not moving. Okay. A is moving. A is moving with respect to what? With respect to OG. A is moving with respect to OG. So you can get that by doing what? This 3.
Yes.
3, right? OA or AG. You know. So that's 3 cm, right? So that's what? 20 meter per second square is equal to what? 1 cm. So 3 cm is equal to what?
3 times 20 divided by
O prime A prime. That's what? 20 times 3 over 1. That's 60
Yes.
meter per second square.
squared.
So, which other one again? So you can calculate it. That's the difficult one is the one that we have done. So it now depends on the question you have. What's the question that we have? Let's check. Angular velocity and angular acceleration of the connecting rod. Angular velocity and angular acceleration of the connecting rod. Connecting rod is AB. AB. We've done angular acceleration for AB. This is it. Angular velocity for AB. What's the angular velocity? Angular velocity is what? Velocity AB is equal to what? AB times angular. Okay?
Yes.
That means WAB is equal to what? VAB all over AB. You can do that one. So what's our VAB from our table? VAB is 2.65. So 2.65 over AB. What's our AB? AB 0.6. 0.6.
4 points.
WAB 2.6 over
0.6. 4.42.
4.42 radian per second. That's what the question asks for. Calculate and linear velocity and acceleration of this. We have done this one. We have answered everything. So any other thing you want to do, just follow the procedure. You get. I want to write it from the board. PQ 62 point.
Ilé ìgbésí wa ní kámẹ́rà Bọ́lá.
So the length of the links are PQ 62.5 mm, QR 175 mm, RS 112.5 mm, and PS, which is 200 mm. The question says the crank PQ, that means PQ 62.5 mm, represent the length of the crank. Okay. Length of the crank 62.5 mm. That's the length of the crank. While the length of PS is fixed, which is 200 mm. That's 200 mm. So, no, from what we have here, we have to take a scale. The first thing we do is step one. Step one is what? Determine your what? Your scale. What can we use as our scale? If we have 20 cm, we don't need to draw over the entire page. You know, 20 cm is almost everything. So let's pick a scale that is convenient for the size of paper we have. Okay, let's 200 mm, which is what? 20 cm. Let 200 mm is 20 cm. 100 mm equals to what? 10 centimeter. If 200 mm is equal to 10 centimeter, that means we are using, in terms of centimeter, that means we are using 2 centimeter equals to what? 1 centimeter. Because we are using the scale of what? 10 centimeter is equal to 200 mm. If the fixed link PS is 200 mm, that means it's 10 cm. So let's draw that. Let's draw that. That's 20 or 20. That's 20 cm, which will now be 10 now. Will give us what?
10 cm.
From this place to this place. Okay. That's what? P.
Yes.
Yes. The question says PS is what? Fixed. To show that it's fixed, then you hash the bottom like this.
Okay, o sanwó dàgbàsókè ló máa jẹ wá.
So the crank PQ is what? Rotating at what? 60 degree clockwise. 60 degree clockwise. I told you something the other time. I said, why don't I put B here and put X here? The question further explains that the side QR is on the same side as what? PS. Yes. If I put P here and draw 60 degree to this side, that means it's already going to the other side. So now let's draw our Q, 60 degree, the crank. Okay. So 60 degree. This is 10, 20, 30, 40, 50, 60. That's 60 degree, right? Yes. So this 60 degree, right? 60 degree. Okay. But the dimension of what? PQ is what? 62.5 mm, which is what? 6.25 cm. If I've said 200 mm is equal to 10 cm and 2 cm is equal to 1 cm, so 6.25 cm will now be what? PS PQ 3.125. Now, so 3.125. You can see I'm fast here. Instead of wasting my time on the board. 3.125. That will be between 3.1 and 3.2.
Yes.
So that's what? Point what? Q. This point Q. Okay. So the question now says that QR is what? 17.5 cm. 17.5 cm now. According to our scale, divide by 2. QR is what?
8.75.
8.7.
No, 8.75. Correct, sir.
cm, right?
Yes, sir.
8.75 cm. Now you will now use this compass to get 8.75.
Yes, sir.
I'm sure you understand better now.
Yes.
8 point. This is 8.5, 8.6, 8.75. So since we are not given the angle, we just bisect. That's QR, Abi. You come here to this point of Q, you bisect 8.7 distance like this. Okay, you bisect 8.7 distance like this. Now we now go to what? RS. RS is what? 11.25 divided by 2 now. RS will now be what? 5.625. You've done it before? Yes. 5.625. Please use calculator. Yes. Please use calculator for me.
That's the correct answer.
Okay. Oba is saying àti ṣe débẹ̀. You, Oba, I pray you will be able to pass this course. 5.625. Amen. Oba, you have mouth too much. Your mouth is too much. 5.625.
Comedy there, come on. Gbogbo magi mi ló ti jẹ tán.
Skit maker.
Ó lọ lé lóúnjẹ ó tún jẹ magi.
5.625. Then, if XR is 5.625, then we use our compass to measure it. Then you bring it here. You bisect. So the point of intersection is your what? Is your R. Do you get it now? Yes, so this is R. This point is our R. Then we now join it. Now join. Join it to. This is the simplest one, no? You now join it. Now join it.
Fatai, soon down.
Now join it. You join it. Okay.
Decorum, please. Decorum.
You join it.
I download the line.
Nice over.
Okay. Now, this is what we call space diagram. From space diagram, we will now move to our what? Velocity. So this is our space diagram, which is the step 1. So we've calculated our what? V. What did we calculate as our V? VPQ, right? Is equal to what? It's equal to R omega. Yes. And VPQ is equal to what? PQ omega. And PQ is the distance of what? P to Q. Which is what? PQ is 0.0625. That means you use in meters, okay? You know we want to get linear velocity from angular velocity. Yes. And linear velocity is in meter per second. So you use the one in meters. That's what? VPQ 0.0625 times 10, which is what? 0.625 meter per second. Okay, so that is it. There's a point I want you to know. When you have a fixed point, when you want to move your space diagram, this is space diagram, when you want to start drawing your velocity diagram, your fixed point or the fixed link stands as a single point. It doesn't stand as a length. It stands as a single point in your what? In your velocity diagram. In your space diagram, it can be a length. But in your velocity diagram, in your acceleration diagram is what? It's going to be a single point. So transfer it down to point PX. This is PS. Okay, if I'm on the board now, how will I be holding all these things together? So let's draw PS to PS now. Okay. We've drawn a perpendicular line to PQ. To PS rather. Yes. This is the perpendicular line. We transferred it to PS. Okay. That means our PQ is at this side. Since P is fixed. Okay. So that means it's moving from P to Q. So the vector will be moving to this direction. You get my point? So from P, this is our what? CS. So if 1 cm is equal to 0.1 meter per second, and VPQ is what? 0.625. That means if 0.1 meter per second is equal to 1 centimeter, 0.625 will be equal to what? It will be equal to 6.25 cm. So from this point, draw 6.25. 6.25. I've drawn double line. Okay, that means from this point, right? These are what? Q. Do you get it now? Yes. That's 6.25. Let me measure again. 6. This one I've entered 6.3. Okay. 6.2. Okay. That's almost entered 6.3. So that's our what? These are what? V what? PQ or VQ. So now, we draw another perpendicular line to what? QR. QR. Then we draw another one perpendicular to RX. QR. A line perpendicular to QR. A line perpendicular to QR. R is moving relative to Q. That means a line perpendicular to QR, you must go and end it at Q. Okay, this is perpendicular. So that's 90 degrees to Q, right? And a line perpendicular to what? R X. Sorry. You end it at what?
Yes.
Okay.
Sir,
Yes.
that last one, can you explain it? Yes, this last one. How we get it?
Draw perpendicular line to any of the things. Okay. RX. R with respect to S. Then you take it from point X to R. So anywhere they bisect each other, the same way we did it here. You get my point. I'm sweating.
This space. All other side. And this plate window.
Okay. Draw the velocity and acceleration diagram. This is velocity diagram. When the angle QPS is 60 kilometers, find angular velocity and angular acceleration. We only have angular velocity for the length PQ. So we can find angular velocity for the remaining. How do we find angular velocity for the remaining? First, let's find the velocity for what? We found that of PQ. Let's find for what? RQ and what? PR and what? PQ. You know what you do? Pause it and send that one. Then you start again so that the thing will not be too much.
No update, don't try.
Okay. Now, we want to get the velocity. All these dimensions now are now velocity. Because we use velocity to do CM. Now, when we measure all this place now, we convert it back to the velocity that we are looking for. So the velocity of what? RQ. And what? RP, right? And what? QS. RQ and RP or PR, anyone. So for PQ now, sorry, we know the one of PQ. Crank, Abi. So let's measure QR is equal to what? 3.1 cm. 3.1 cm. We used 0.1 meter per second is equal to what? 1 cm. So 3.1 times 0.1 will give us the meter per second of QR. If we use 0.1 meter per second is equal to 1 cm from our scale, that means what will be the meter per second of QR? That will be 3.1 times
0.1.
That will be what? 3.1 times 0.1. That's what? 0.31 meter per second. That's the velocity of what? That's the velocity of QR. 0.31 meter per second. Yes? You measure it with ruler. Okay. RP. Where is it? Where is RQ? RQ. I said the answer is 2.929. The answer in the textbook is 0.3, maybe 0.33 or 0.32. Do you understand? This one is even more accurate than the one I did before. So we measure RP.
RP, sir. QP. 6.4. No. 6.3 something.
QP 6.3. QP 6.3. That's 6.3 times 0.1 meter per second. Huh? QP. No, sorry, we don't need QP. QP, we have QP. That's 0.625. We got 0. It's almost is correct. So, so it's not. We have that one. It's RP that I need.
5.1.
RP 5.2 cm. That's 5.2 times 0.1. That's what? 0.52 meter per second. 0.52 meter per second. QS. So no, it's RS that I need. I've done. It's RX.
It will still be the same thing, sir.
I think it's 2.
Okay.
Abi? It's 2. QR. I've done QR. I've done RP. I think we have everything. We have PQ. We already have PQ. QR. We've done QR. RS. RX. It's RP. RX. It's the same thing. It's the same thing. So which other one? PS is fixed. PS is fixed. So we've done it. So that is it. Now we have gotten our what? Our velocity. That is what? The question says find the angular velocity. What we found now is velocity. Now we want to find angular velocity. Find the angular velocity from our formula that says V is equal to R omega. So VRQ is equal to what? RQ omega. Omega is the angular velocity. Omega RQ is equal to what? VRQ over what? RQ. RQ is the what? The distance of the length. So this one is now. What is our VR? What is our RQ? 0.31. What is our RQ? RQ is what? 0.175. 0.175. So calculator.
1.77.
1.77. Please, oh,
Yes, sir.
radian per
Seconds.
seconds. So the next one is what? Rx. V. That will be W. Rx is equal to what?
0.5.
V Rx over what? Over Rs. VRX is what? 0.5 over what? Rx.
0.11.
0.1125.
4.62.
4.62
Radian per second.
seconds. So these are the angular velocity we are supposed to find in the question. The next one is now find angular acceleration of the links. To find angular acceleration, this one, crank PQ, we were only given angular velocity, we were not given angular acceleration. So if we are given tangential acceleration, that means we will find the angular acceleration. But since they said it's rotating at 10 radii per second, and they did not say that the speed is fluctuating, if the speed is the same, that means we cannot have angular acceleration for that one, for crank PQ. But we'll find for the remaining ones, which is this one and this one. So that's why I left the table open here. No tangential acceleration since angular acceleration is not given. If it is stated in the question that the speed of the crank is 10 radii per second, but it varies, it later varies, that means we can find what? Tangential or all this angular acceleration. But since they did not talk about it, that means the speed is fixed. So this, no tangential acceleration for this. All these ones that we found now is angular. All this one is what?
Angular velocity.
Angular velocity. All this one is what? Velocity. Where is the velocity? All this one is velocity. So let's form our table. Form our table.
That's one zero.
No, I will still draw R. Let's form our table. We have formed the table in what I have here. In the note I want to give you, I formed the table, but I've decided to form another table with the one we calculated in the class. So this is the table. The velocity 0.31 meter per second. This 0.31 meter per second. This is it. 0.25 meter per second is 0.25 meter per second. Px is fixed, so Px has no velocity. So now we want to move to acceleration. Acceleration has two components. It has both radial component and tangential component. The addition of radial component and tangential component is equal to the acceleration. So we first deal with the radial component before we move to the what? Tangential component. So now, if you want to draw the acceleration diagram, you will take another one, another scale. From our what? From our what? From our what?
Velocity.
From our velocity. So please be comparing what we have here to this one. If it's different, I think everything is still the same. This one is even more accurate, except the interchanging of the drawing. The R is here and the... So now, okay. Now we're going to the acceleration diagram. We pick another point, Px. We have picked Ps here for velocity diagram. Now when we want to go to acceleration diagram, we put it P prime X prime, so that you will know the difference. You understand what I'm saying? That's why I have P prime X prime. So we first take our scale. Okay. So which scale are we using now?
I think we have used 0.0.
Is 0.2? No.
it that one or the first scale?
Which scale are we using now?
We have used
And the coming
0.18.
This one is for velocity diagram.
Now for
Acceleration diagram. Which scale did I even use here? For velocity diagram. For velocity diagram. VRX. What's our VRX here? 0.51. Have you? So no. Where is it? VRX is 0.5. My own here is 0.52. VRQ is 0.31. This one is 0.29. It's very similar. So find the angular velocity. I think we've done that. Yes. We've done angular velocity. Yes. We did it here. So what next again? We've done that. 4.62. 4.4. So everything is similar. The other one is 1.77. This 1. No. This is 1.65. So it's similar. So now acceleration diagram. Okay. Let's draw our acceleration diagram. Biro. See, to draw our acceleration diagram, we first start with this. The velocity. Since we are not given what? The angular acceleration. That means this radial acceleration, this radial component is the only one we'll get for the first one. Since we are given the velocity of the crank, we are not the one calculating for it. So now let's get the radial velocity. This is 0.625, right?
yes, sir.
Acceleration is velocity over time. Okay? Yes, rate of change of velocity with time. That's acceleration. So rate of change, acceleration is equal to what? Rate of change over time. Of change of velocity with time. So if we have our velocity as 0.625, I want to find our radial acceleration. That would be what? V PQ, right?
Yes.
Over what? PQ. PQ is the R. Do you understand? As our what? Acceleration for this particular one. So that would be what? 0.625 over what? Eh?
Over 0.0625. 0.0.
Are we using length?
Sorry,
Length.
0.
Leave the length.
PQ go.
What's our PQ?
PQ is 0.06.
0.0625. Yeah, divided. What's the answer? 10? No, it's wrong. Is it what I have here that is wrong? See now. Oh, sorry. I've forgotten to put square. Oh yeah. What's the answer?
6.25.
Okay. 6.25 meter per second square. Okay, so we fill our table. 6.25. So now, meter per second square is already at the top. So what we now do now, let's draw our what? Acceleration diagram. We will now pick another scale. Your scale, right?
Yes, sir.
Now we have this as 6.25. So let 1 meter per second square equal to what? 1 centimeter. Right? Do you get my point now? So okay. I think I will have to draw here. Let me put my points here. We drew in velocity diagram that are perpendicular. when we get to acceleration diagram, we draw it parallel. Okay, this is point PS, right? We want to get what? We want to get PQ, right? PQ. If you look at this PQ and this PQ, you see that this line and this line is parallel.
Yes.
But in this one, PQ is perpendicular to this PQ. So the difference between your acceleration diagram and your velocity diagram, when you are drawing your velocity diagram, you draw lines perpendicular to your link. But when you get to acceleration diagram, you draw parallel to those links. Okay?
Yes, sir.
But there are lines you will draw perpendicular, but it's not from this link. But anyone you are bringing from this link to acceleration diagram, it must be parallel. So the same way I said, the fixed point, the fixed link will be represented by a point, just like this point px. So now let's represent px, which is fixed, with a point. P point P prime S prime, just to show that this one is acceleration diagram. So now let's get PQ. Let's draw a line which is parallel to what? PQ. PQ. How do we get a line that is parallel? We need a parallel line. We need to transfer. How do we transfer all this transfer now?
Do the other sense.
Why don't we use let us use the second one?
Let's use the second one. You can use both this together.
Is this transfer gone that is wahala? Like this? No, I want to move it here. No, it can't touch this place.
If you touch it, if this one comes down like this, this one will be coming up.
It can't touch this place.
If this one is coming up.
So I'm moving. Different. If I use my hand to move it, it's accurate. But if I want to move it back, it will shake. But if I move it like this, it's accurate. This is not my first time of doing it. But if I want to do it back, it may not be correct. But if I do this way, it's correct. But there is a way I used to do it with this too. You know, it's been a long time. It's once in a section I used to there's a way I used to use this thing. Okay. Am I correct like this? Are you sure?
Why don't you use ruler in that place? Ruler in line. I want to use ruler.
Okay. Ruler will do it. Ruler will do it. If you score 0, I will not pardon you.
Mo phone never said good.
If you perform woefully, I will leave it like that. You will beg everybody to beg me. I don't listen. People that know me very well, if I want to deal with somebody, if you like shout from today to next year, you will suffer for it. Mo fara wí Ṣẹ́gun tí ò ní kúrò ní WhatsApp mi. Orí ẹ̀ máa pé. Tá máa kí mi, tá máa message mi, tá máa mo fara wí. Tó bá ti ní CEO tó gba yí, ìgbà yẹn ló tó máa yí ẹ. Inú ẹ̀ ṣe ní fara wí. Ṣẹ́gun that can message me 12 a.m. He knows I don't sleep early. You are using your own to compare Ṣẹ́gun. Máa compare ara ẹ pẹ̀lú ẹ̀. I and Shegun, we stayed in the same street when he was in ND.
Báwo ló ṣe mọ ní sẹ́gun? Báwo ló ti sẹ́gun?
I think it's okay now. Yes. Right. It's okay now. So. Okay. Now, we've taken our scale as what? 1 meter per second square is equal to 1 centimeter. So we want to get our what? PQ. We want to get our PQ. P prime X prime P comma, sorry. Q. So since it's coming this way, so it's going to be downward. The direction of the vector will be downward, okay? If we actually do something like this, this one is 60 degrees, right? This is first quadrant, second quadrant, third quadrant, fourth quadrant. If it's on the first quadrant and it's moving clockwise, you should know it's coming down. If it's on the fourth and it's coming down, and it's on the fourth quadrant and it's clockwise, it's still coming down. But if it's on the third, it's already going up. But it's in the second, so it's coming down. Okay? So we've transferred this parallel line to this place now. We said 1 meter per second square is equal to 1 cm. And what do we have? We have 6.25. So 6.25. 6.25 is 6. 1, 2, 5. This is 6.25. Okay. That's our what? This is our Q. Okay. Now, we want to move QR. QR. What's our QR? 0.3. From the table, 0.31. QR. QR, we transfer a parallel line from QR. We want to move QR. A parallel from QR to this point. Let's transfer a parallel line. How do we do that? The same way we did.
This one first. This one will be
A parallel line. Can this be the parallel line? It will go up. It will go up. So be dragging that one down. Okay. No. Oh yeah. Okay. No.
Only the middle.
This one. It's okay. Go up,
Please, if you want to get these things easily, there is one set square that used to have compass inside it. You know that set square one used to have compass. That one. Huh? No, is it bigger than this?
Yes.
Is it that one? No, this one I'm talking about is like this. It has compass inside.
Yes.
Is it this one? It's not this one. It's not this one. That one used to have compass like this inside it. The hand, something like this will be like here. They will do it here. You don't understand what who is the owner of this? So now we are transferring the parallel line from QR to Q to get our QR. So to point Q now. Okay, drag it. Okay. QR. Okay. QR. What's the, is it? It's not correct. This our transfer is not correct.
Zero.
0.31. 0.31, and our scale 1 meter per second is equal to 1 cm. So that means we are measuring 0.8. When you finish this one, go and be teaching people in mechanical.
Okay.
Huh? Why are you saying huh? Why?
He cannot get it.
Yeah, okay.
He has limited himself.
Yeah, okay.
You also joke.
Because you limit yourself. Me, I will get it. 4.2. 4.2.
Okay.
Okay.
The man overlap.
Yeah.
81, 4.2 already.
Okay. 0.3 Abi? 0.3. 0.3. That's 0.3. That is 0.3. This one I'm drawing is the radial component. Okay.
I want to ask a question.
Yes.
Yeah, you use 6 point here. 6 point something here. We should use 3.1 something. Sir.
Where?
Yeah, the first one. You use 6 points. In the middle, when you measure it, I'll use 6 points.
In which place?
The first one.
You know, you can
Yeah.
put it
The Q prime.
I use 6.25.
Yes, this one you
Why
should use
didn't you calculate for
3.1.
this one too as we did it? I did this one. 6.25.
I don't understand what are you saying.
You only make use of
0.3. It should be 3.1, sir.
No, you calculate.
No, you calculated for angle of acceleration here.
I don't get what you are
Àwọn
saying.
fẹ́ kẹ́ lò pé ní 0.31 instead of 0.3
No, that's what she's saying.
The first measurement,
acceleration.
This one, sir.
You calculated for this one here.
So the first measurement from this prime, P prime and S prime here. When you measure it to Q prime here, you use 6 centimeters, sir. 6 centimeters. The next one now, you now use 0.3 centimeter. It should be 3.1 centimeters.
No, go take the 30.1. Eléyìí máa jẹ́ 0.1 square.
Oh, I understand what you're saying. Use this one to divide this. Square this one.
0.5.
0.5.
0.5 what?
0.55.
Please, all these things vibrating in my pocket. Don't use your own to disturb my life.
Yes, you can.
Square.
0.175.
0.75. It's equal to 5.5. 0.5.
0.55. You know
If we
what?
want to multiply 0.55 multiply by 1, sir, it will give us 5.5.
Meter per second square. Yes. You know what, you people, don't confuse my life, please. If you look at what I have here, if you look at what I have here, this place to this place is 0.29. Check it. which is 0.3. Is it? Or what is it? What is this one? 0.5. I think.
0.5.
Okay. 0.55. .55. Okay. The one I just drew down. The one we are drawing is radial component here.
Yes.
0.55. So to draw the tangential component, you draw a perpendicular line. Give me. Okay, we draw a tangential component. You are you make a dotted line. So this is PQ. This Q, we are trying to draw QR, right? We are trying to draw QR, but you can represent this point with any alphabet. This is the radial component of R. This is the tangential component of R. But we can't call this place R. When we continue to draw, when it intersects, that will be our R. So you can decide to call this place any alphabet. Maybe you call it X. So let's now draw. This is Q. Let's now draw X R. XR. We've drawn PQ. PQ is this parallel. This is QR parallel to QR. That's what we brought here. So let's now draw RX parallel to RX. A line parallel to RX. This is, we need a line parallel to RX at point PX. So if this is the line, how do we get a line parallel to this? If we drag this a bit, it will give us. Which other thing can we do? Okay, let me use this. Let me use this. Right?
Yes, sir.
This line is parallel to.
Yes.
Alright. This line is parallel to RX. So RX. Where's my table? RX 0.52 over 0.1125.
2.40.
2.4. No, square.
Reduce everything. Yes, reduce everything.
0.252 all over 0.1125. Oh yeah.
2.40.
2.40. So let's measure 2.40. 2.4. Parallel line at 2.85 cm. Which unit did we take? Did we choose any unit? Pick 1 meter square from our scale. From our scale, 1 meter per second square is equal to what? 1 centimeter. So that means A tangential QR is what? QR is what? 2.85 meter per second square. So the other one is what? Rx. Where is A tangential Rx? This is it. This is 4.5. This is 4.5. A Rx is equal to 4.5 meter per second square. So, who is that? You want to blow powder on my head? So now, we have to find what? The question says find. We have found this and this. Fill it up.
2.85. Yeah, 4.5.
So now, that is the tangential acceleration. But the question says find angular acceleration. Angular acceleration is acceleration is equal to what? Acceleration radial plus acceleration tangential. Okay? Acceleration radial is v square over r. Okay? I have the formula here. Acceleration radial is what?
V square over r.
Why acceleration tangential is equal to what? Alpha times r. Where r is the distance of the link. So now that we have a tangential for this, for QR we have what? 2.85 as our a tangential.
Yes.
We are looking for angular acceleration. That means a tangential, which is equal to angular acceleration times r, will be what? 2.85 is equal to what? Times r. We are 2.85 over r.
Yes.
What is QR? What is QR?
QR is
In meters.
In meters. 0.175.
0.175.
You should see, yeah.
Yeah.
$16.28.
16.28. As angular acceleration, that's meter per second square. That's for QR. So then for RX, we have 4.5, Abi?
Yes.
That'll be 4.5 over
0.1125.
0.1125.
40.
Equal to 40.
Meter per second square.
That is the answer.
So
So
plus it together.
now, if you now want to find this one, you had this and this. What is here?
4.5.
4.5.
Yes, sir.
So we have. Where are we going to? Which table are we going to put this one now? Okay. Should I put it here?
Yes.
Huh? It will scatter.
Yes,
Or I should put it here.
Put it on
sir,
that.
let it call she saying here.
Okay, let me put it here. R 40 meter per second square. R QR 16 meter per second square. So to get our acceleration now, add this one and this one. 0.55 plus 2.3.4.
3.4.
This one is also in meter per second square. So this one 2.40
6.95.
plus 4.5 6
0.95.
6.95
4.5, 6.9.
6.9.
Yes.
So this is the acceleration. This is What is it? So, what? Which plus? Don't worry. When I give you notes, you will read it in the note. I have written everything. See it. AR plus A tangential. You've seen it? Okay. So, my question now is, we've calculated by adding A radial with A tangential to get our A, which is acceleration. Let's now go to the diagram and measure if what we have will be similar. Okay? QR is 3.4. Let's check if it's going to be similar. 3. 1. This is acceleration QR, right?
Yes.
This one is 3. The other one, RS,
3.39.
6 points.
You should have like 7.
So it's better we add it. So always add it to get your answer. Okay?
Can I answer? Any questions?
Yes, I've seen a question I want to ask right now. So what I will do is, today's question has been sent to your WhatsApp. The note, the note, okay? Follow this. Wait, snap this. Snap this. Are you through with recording? B. A, B. I think this thing is only drawing. It would have been fine. It's both drawing and calculation. If you don't know the calculation, you can't know the drawing. If you don't know the drawing, you can't know the calculation. You can see everywhere feed up. You can see another page feed up. Okay. You know the funniest thing? Some people will not come to class. They will be in class. They will sit at the back. They will still not know it. They will be looking for somebody to teach them that they were in the same class. Some will sit at the back. If you check this class now, some will be at the back. How will Said see what I'm doing? He cannot see. I talk to HOC anyhow. He was my project student. I can vouch for him. I can vouch for all my project students. Except Yusuf. Except Yusuf. Naira. Yusuf. Baba Were. Is your husband? Why are you selling pomo? Your husband is driving. Okay. If Yusuf is your husband, you are supposed to be driving Lexus. She shows to sell pomo.
You're supposed to be selling clothes na rent.
Yeah, I think we right. This is already above it. Should we take it like that?
No, the measurement of my own calculated.
It's above it, like point something.
Yes.
Let's just continue.
Yes.
I remove 0.1.
Like 0.1.
So that we will not get wrong answer. Okay. So now, this is what? AB, right? This is the radial acceleration for AB. At what? 0.58. 0.58. What do I have here? My own is different. My own should be up to. Mine is 0.9. Diagram is because of the diagram. That's why we have different answers. 0.58. That's like 0.6,
Yes.
right?
Yes, sir.
0.58 and 0.9.
0.6.
So okay. So at this point, after measuring it, these dots, that's the point where you withdraw your what? Tangential acceleration. Okay. Then okay, this is 90, right?
Yes, sir.
Then you have something like what? Like this. Like this. Okay. Are we in line?
Yes.
Okay. Two. Okay. Now we need what? This OG. AG. AG or AO. There's movement of A with respect to O. If our fixed point is OG, there's movement of A on this OG, but the movement is like this. The movement is like this. Because if this crank, this is a crank, from here to here is a crank, is rotating this way. I have it here. This OB, this OB, this is the OB, this place to this place, and this one is rotating clockwise. It's rotating clockwise like this. So when this thing move to this place, it will drag this thing, and this thing will drag this one. So this one is here. So there's movement of this A with respect to what? This place to this place, with respect to 0 to G. So that means this one, this point cannot go like this. It will only go this way. So that means we need something parallel to this. Then something parallel to this must be in line of what? OG. That means we need a parallel line which we will move from here to point OG. Do you get my point?
Yes, sir.
This is what? Tangential acceleration for what? For A, B. This point, this one is radial acceleration for AB. This tangential acceleration for AB. So moving this one, how do we get a parallel line to this? If you know this diagram, the calculation is not going to be a problem because the calculation is not hard. You understand? The calculation does not have plenty formula. It's the diagram that is problem. That is the problem of okay. Okay. Right. I think we have successfully transferred it. Right? Right. Transfer it to G. Okay. So this point is your what? Is your A prime. If this is the radial acceleration for AB and this point to this point is the tangential acceleration for AB, the acceleration for AB itself will now be from this place to this place. This will now be the acceleration for what? AB, which we can call acceleration of A because it's A that is moving with respect to B. You can also say acceleration AB is equal to what? Acceleration of A because it's this A that is moving with respect to this. So this arrow will come this way. Do you understand? So now we are almost done. Are we not almost done?
Yeah.
So what we need now to do is to measure and to calculate. So what is the tangential acceleration for BA? Where is BA? BA. Tangential acceleration for BA. You measure from here to here. That's what?
6.3. 6.3. 3.5.
6.35. A tangential AB from measurement from or from acceleration.
Yeah, okay.
Okay.
That's it.
It's 6 point what? 6.5, right?
3.5.
35.
Yes.
This should let us not have. What's there?
The 6.35. Or what was it?
6.35 cm. Okay.
Yes, sir.
If 20 meter per second square is equal to 1 cm,
Yes.
so A tangential AB is equal to what?
6.35 divided by 20.
Is equal to what? 6.35.
Divided by
That's what? 6.35 times 20 all over what? 1 is equal to A raised by TAB. So 6.35 times 20, calculator, sharp.
6 point. Divided by 1. 6.35. 127.
127. 1. This one is 6.35, abi? 127 meter. 127 meter per second square. Okay. So now we know that A tangential AB is equal to what? Angular acceleration AB times what? AB. A tangential AB over AB is equal to what? Angular acceleration AB. So 127 over AB. What's AB? AB 0.6 is equal to what? So angular acceleration AB is equal to what?
1.6.
1.6 meter per second square. So which other one are we looking for? That's the what? We've done for AB. We've brought out the tangential acceleration. Which other one again do we need? Any other one you need, you can bring it out, right? Which other one should we bring out again? Where's our table? We've done for this, right? We've done for this. So when you get this, we've calculated for this. When you have this, when you have this and you have this, you can have this. If you want to go and use ruler to measure it, you can go there and use ruler. This acceleration, you can use ruler too. Okay, but if I want to give you a question, I will tell you that what's the difference between your calculated acceleration and the one from your acceleration diagram? That means I expect you to add your tangential acceleration and radial acceleration, give me the acceleration, then go to your diagram and measure if there's any difference. You understand my point? So you know, if we measure here, what we just do is to convert it based on the scale and get the acceleration at this point. Narrate, are you getting it? You are getting it, okay?
Yes.
Kunle, Onodeko, more plantation, Agosu. Where is Oba? Stay here. Stay here. Where they can shoot you with me. Who's your wife? Who gave her to you? I can never give Ramot to you. I know. I assigned her to you to deal with you. It's not for her to marry you or to be your girlfriend. If I want to assign Ramot to someone, I know the type of people I can assign Ramot to. You. If I assign you to Ramot, no. You are not compatible. I know the kind of guy that can fit Ramot's life. So we've calculated this. We've made, so which other one? OG is not moving. Okay. A is moving. A is moving with respect to what? With respect to OG. A is moving with respect to OG. So You can get that by doing what? This 3. 3, right? OA or AG. You know. So that's 3 cm, right? So that's what 20 meter per second square is equal to what? 1 cm. So 3 cm is equal to what? A O prime A prime. That's what? 20 times 3 over 1. That's 60 meter per second square. So this other one again. So you can calculate it. That's the difficult one is the one that we have done. So it now depends on the question you have. What's the question that we have? Let's check. Angular velocity and angular acceleration of the connecting rod. Angular velocity and angular acceleration of the connecting rod. Connecting rod is AB. AB. We've done angular acceleration for AB.
Yes, sir.
This is it. Angular velocity for AB. What's the angular velocity? Angular velocity is what? Velocity AB is equal to what? AB times angular. Okay?
Yes.
That means WAB is equal to what? VAB all over AB. You can do that one. So what's our VAB from our table? VAB is 2.65. So 2.65 over AB. What's our AB? AB 0.6. 0.6.
4 points.
WAB 2.6 over
0.6. 4.42.
4.42 radian per second. That's what the question asked for. Calculate linear velocity and acceleration of this. We have done this one. We have answered everything. So any other thing you want to do, just follow the procedure. Get it. So what I will do is now, some of you complain that you don't want it on your phone, that you want something you can see. So bring the 2 I gave you. So plus these 2 is for last week. It's the same thing, but solved in 2 different places sheets. But it's still the same thing. You can see it's still